Hello everyone, this is Junaid here from Edureka and I welcome you all to this session in which I'm going to talk about object detection using YOLO algorithm and OpenCV. So without any further delay, let's take a look at today's agenda. We'll start this session by understanding what is computer vision and why we need it. Then we shall discuss both machine learning and deep learning approach for object detection. Moving ahead, I'll be speaking about how OpenCV can be used to pre-process our images. Finally, we'll discuss about both YOLO and CNN algorithms to object detection and see how we can implement it. Before we begin, consider subscribing to our channel and hit the bell icon to stay updated on trending technologies. And also, if you're looking for online training certification in Python, check out the link given in the description box below. To start off, let us now understand what is computer vision and why we need it. So what is computer vision? Well, you see, computer vision basically deals with anything that humans can see and perceive. There are so many tasks that we humans do subconsciously that we hardly think are even worth mentioning. However, for a computer to learn, to perform, or even try mimicking such things is very difficult. To give you a better understanding of what I'm talking about, imagine looking outside a window. What do you see? You might be sitting in an office building and seeing a traffic outside, right? So do you ever wonder how you recognize something or someone? Do you know how you can look at someone and know who they are? Well, you see, subconsciously we are identifying objects in any image you see. Then we try to find what relation exists between the object to identify the scene or a place. Only then we get an idea of what is happening in an image. Sometimes we can also look at an incomplete image and use our knowledge and previous experience to determine what is missing from it. All of these are the task of computer vision. Speaking about different tasks of computer vision, we can perform various tasks like object detection, object classification, image captioning, and image reconstruction. I'm sure you might be wondering what does this task do, right? So let's now discuss each of them in brief. Object detection is the ability to detect object or identify object in any given image correctly. Then we have image classification, which basically means to identify what class the object belongs to. Image captioning is nothing but looking at an image and describing what is happening in an image. Last but not least, we have image reconstruction. In image reconstruction, we basically have the ability to identify what is missing in an image in order to reconstruct it. Now that we have gone through object detection and gained knowledge of what we can do with it, let's now see how it works. There are two main approaches for object detection, that is machine learning approach and a deep learning approach. Both of these approaches are capable of learning and identifying the objects, but the execution of them is very different. Starting off with machine learning approach. Machine learning is the application of artificial intelligence for making computers learn from what the data is given to them. Here they can make decisions on their own similar to that of human beings. It gives computers the ability to learn and make predictions based on the data and information that is fed to it through the real world interaction and observation. Machine learning basically is the process of using algorithms to analyze data and then learn to make predictions and determine things based on the given data. Machine learning methods for object detection are SIFT, then we have support vector machine, and then we have Viola-Jones object detection framework. Moving on to the next method, that is deep learning. Deep learning, which is also referred to as deep structured learning, is a class of machine learning algorithm. Deep learning uses multiple layer approach to extract high level feature from the data that is provided to it. Deep learning model does not require any feature to be provided manually for classification. Instead, it tries to transform its data into an abstract representation. Deep learning is also influenced by artificial neural network present in our brain. Most of the deep learning method implement neural network to achieve the results. All the deep learning models require a huge amount of computational power and large volume of labeled data to learn from the features. Some of the deep learning method for object detection are RCNN, faster RCNN, YOLO algorithm, and the faster RCNN. Moving on, let's speak about open source tool called as OpenCV. OpenCV is a huge open source library for computer vision, machine learning, and image processing. And now it plays a major role in real-time operation, which is very important in today's system. By using OpenCV, we can pre-process images, videos to identify objects, faces, or even handwriting of a human being. When it is integrated with various libraries such as NumPy, Python is capable of processing the OpenCV array structure for an analysis. As I mentioned earlier, we use OpenCV tool to pre-process our data. Let me now quickly jump to my code editor and show you how I can use this to manipulate our images. All right, as you can see here, I'm using my Google Colab as a code editor. So let me quickly give a name over here as demo. And let me start off by writing our code. So first off, you might be wondering, how can I install my OpenCV, right? So it's pretty simple. In order to install your OpenCV, all you need to do is pip install OpenCV Python. All right. And after this, all you need to do is shift enter. As I'm using Google Colab here, it comes pre-built in our system. But if you're trying to download this on your system, you can just type this on your command prompt. Now, let's import our OpenCV, import CV2. And also a matplotlib, import matplotlib as plot. And then let us also import our numpy, right? Okay, let me quickly execute this. Fine. And let us now have an image over here. Let's give a variable image. And let's see how we can read our image using OpenCV, right? So cv2.readImage, and then we're supposed to pass a URL. All right. So let me now quickly upload our image over here. Okay, you can see I have a couple of images over here. Let me quickly select this image and upload it. Okay, let me copy the path for this and paste it over here. All right, so the reason I'm using dot over here is because we are in the same directory, right? So let me execute this part over here. Okay, and let's see the type of this image. You will see that this gives us a numpy array, right? If you're trying to read an image using OpenCV2, the image is going to be in the form of BGR, wherein it stands for blue, green, and red. But we don't want that. Okay, before I move ahead, let me just show you what is the size and shape of this. Okay, so image dot shape, and let me hit enter. You will see over here we have the width and we have the height, and this is the number of channels. And the reason why we have number of channels is because it's a colored image, right? So it's going to be R, G, and B. As we are using OpenCV2 to reconstruct our image, we have to convert this back. Okay, so let me quickly show you how our image looks like. So in order to read our image, I'll use plt.imshow image. Okay, so this is our image. Now you might be wondering, like, doesn't OpenCV have its own built-in method to plot an image? But yes, OpenCV has a built-in method to plot an image or to display an image. But unfortunately, it is not supported by either Google Colab or Jupyter Notebook. Okay, and as I mentioned earlier that OpenCV reads the image in BGR format, you can see the color has been inverted over here. So let me quickly run this again. So in order to change our color, right? So let me give it as image, or let me give it as new image, right? So it's going to be new image is equal to cv2 dot cvt color. Okay, and this method takes an image over here, and then we're supposed to pass which format we want to convert this to. So it's going to be cv2 dot color. Okay, and now we have to convert this from BGR to RGB. So you can see over here. So let me quickly execute this, and before that, let me plot this image, right? So plt.imshow new image. Okay, then if we are getting an error here, let's see why we are getting this error, right? So before that, let me execute this here. Okay, we are getting this error because it's saying demo scaling, right? So let's see where we are going wrong. Okay, you can see that we are getting an error over here, right? And the reason why we are getting an error is because we have not placed our comma over here. And it's going to be BGR. Okay, so it's going to be blue, green, red to RGB. And let me quickly execute this over here. Okay, let me rerun the image from start. Okay, and let us now see how this image would look like. So plt.imshow. Okay, and then we're going to put our new image over here. Fine, and let's see how it looks like now. So as you can see here, right, there's a huge amount of difference. Okay, so here we have a blue color bus and a red bus in the behind, and you can see there's a lot of difference over here. It's a yellow bus and a blue bus in the back. So the reason why we were getting this is because, you know, this is actually the original image. Okay, and this is what it looks like every time we pick it up from the CV2. All right, So let us now see some more pre-processing or the basic operations that we can do. So to start off, let's see how we can split our images. And when I say split our image, we're going to split all the different channels. So if you can see over here, we have the shape over here as we have X, Y, and then we also have 3, right? So after splitting, it's going to be 1. Okay. So let us now see how we can do that. So, all right, we obviously have 3 channels, right? So R, G, and B, which stands for red, green, and blue. And then all we need to do is cv2.split and new image. All right. So let us now quickly execute this. But before that, let's print the shape. Okay. So print. So we are going to have shape of R, which is nothing but R over here. And similarly, we'll do it for G and B, right? So let me copy this and change the values. So this is going to be green and blue, green and blue. So let me quickly execute this now. Okay, we are getting the entire array here. So what we'll do is r.shape, and same thing we'll do over here as b.shape, and even for G, it is going to be g.shape. And let me execute this. So you'll see here, right, we don't have any more channels. But if I want to print this new image, it's going to be 720, 2 or 1280, 3. All right, so this is all about splitting our image. Now what to do if you want to merge our image, right? So it's pretty simple. We have cv2.merge for that. So let's give the same name, new image. This is going to be cv2.merge, and we're going to pass our channels. And this will be in a form of a tuple. So it's going to be R, G, and B. All right. So this is how we can merge our image. Let's see how we can resize the image, right? So let's see another operation wherein we are going to resize the image. Okay, first off, we need a scale, right? Scale is nothing but by what amount we want to resize, right? So let's give scale is equal to 10. All right. And then we also need the width. So W, which would stand for width, and this would be an integer value. Okay. And then we'll have image, or it would be new image, right? So new image dot shape. And then as we all know, this shape gives us a tuple. So we are going to pass the value, right? So this is going to be the shape present at 1. Okay. And then we'll scale this down by our scaling factor, that is S, and then divide it by 100. And same way we are going to do it for the height. So only thing that's going to change over here is H, and then we'll change this by 0, and rest everything remains the same. So now what we'll do is we'll create a tuple here. So we'll give this as dimension, dim, and this will be having width and height. And now in order to reshape, what we'll do is first we'll have a variable here, resize, and this would be nothing but cv2.resize, and then we are going to pass the original image and then the dimension of the new image. All right, and then we are going to pass our interpolation, which is nothing but an argument over here, and then we'll have cv2.init area, cv2. Fine. So let us now execute this, and but before that, let's print the size, right? So resize dot shape. Okay, and let's execute this. So as you can see here, we have reduced our image size, but the number of channels has not changed. But the value, which was something like 720 and 1080, has been reduced to 72 and 182, right? All right, so let us now see another operation that we can perform here. Okay, so let's see one more operation, that is nothing but rotate operation. Okay, so similarly, we obviously need to have the height and width. So it's going to be height and then width. Okay, and now we'll have new image, and then we'll take shape, and we all know it gives us a tuple, right? So we'll have all the values from 0 to 1. Okay, and now we'll have to calculate the center. So we'll just give a variable rather than center, let's give it as C, and then we'll have tuple value W by 2, and then we'll also have height by 2, because that's how we calculate the center, right? And now let's say we want to rotate this by angle 90 degrees. Okay, so now what we'll do is we'll declare a variable, let's say M, and then we'll have CV2 dot get rotation matrix. Okay, and now we are going to pass center value. Oh, that's C over here, and then we'll have an angle, and at the same time we'll also have the scaling factor. That is, we don't want to reshape our image, right? We don't want to reduce the image size, so we'll give 1 over here. And now we have to rotate, right? So rotate 90 degrees, and this would be equal to CV2 dot wrap. All right, and now we are going to pass our image, that is the new image, and then we'll have M over here, that is nothing but the object over here which is returning, and then obviously height and the width. Okay, so this is going to be the tuple value. Okay, and let's now see how this would look like. Okay, so over here we are having an error, C is not defined. So let us quickly do that. Okay, rather than C, it's going to be 2 over here because we are going to find our height, and let me execute this now. Okay, so it has been successfully executed, and now in order to see our image, right, we have rotated this by 90 degrees counterclockwise. So let's now just print this and see how it looks like. So plt.imshow, fine. So as you can see here, we have rotated our image counterclockwise by 90 degrees. So moving ahead, let us now see how convolution neural network work. Okay, so what is convolution neural network? CNN, or a convolution neural network, is a class of deep learning neural network. What I'm trying to say here is, think of CNN as a machine learning algorithm that can take in an input image, assign importance to an object, and then to be able to differentiate between one object and the other. CNN works by extracting features from the images. Any CNN consists of following 3 things: an input layer, which is a grayscale image. Then we have the output layer, which is the binary or multi-class labels. And then we have hidden layers, which contains convolution layer, ReLU, and then we also have pooling layers. Finally, we'll be having artificial neural network in order to perform the classification. It is very important to understand artificial neural network, or ANN, in order to perform multi-class classification. Let me quickly move to the canvas and show you how CNN architecture is. All right, so as I've mentioned earlier, when we are dealing with CNN, right, we'll have 3 things. That is nothing but the input image. So consider that we have an input image over here, and this is a grayscale image, so the number of channel over here is going to be 1. Let's take image size to be 10, and then we also have image size over here as 10. Okay, in reality we won't have image size to be 10. All right, so this is just for just so that we can understand. And now what we'll do is we'll perform convolution by passing a convolution filter, which would be of a size 3 and 3. This convolution filter will go through each and every part of this image and extract all the important features. So for example, this convolution layer, right? So let's give it this name over here as convolution layer. Okay, now this convolution layer, we can have multiple of them. Okay, we can have, like, suppose 35 convolution layer, and each of these 35 convolution layer are responsible for extracting a very specific features. Okay, so now for example, let's think that we have 35 layers over here, and now this will undergo convolution, right? So this is convolution. We'll get a new image over here, and the new image would look something like, and we'll get a new image over here, and the new image would look something like, this is the actual image, right? Initially it was having single channel. After undergoing convolution, it will have 35 layers, or dimensions I should say. So this would be 35, and the size over here will be reduced from 10 to 8. So if you didn't understand this, right, let me quickly make you understand what's happening over here. So what's going to happen over here is this filters over here, right, this 3x3 filters, they will go on each and every part of this image. Okay, so now let's take image as a matrix, right? So let's take obviously this 10x10. Just for the illustration, I'm going to draw 5x5. So this 3x3 matrix will fit over here. Okay, then there will be a stride. Stride is nothing but how this matrix moves, and then there will be a second stride. So it will go through every 3x3 matrix, and then it will go throughout the image. All right, and then we'll have an image over here which will reduce to 8x8, but then we'll have more number of features. That is nothing but 32 features or 35 features over here. Now, as you can see here, right, we have huge amount of dimensions. So this would lead to cursive dimensionality. In order to overcome this, what we'll do is we'll pass this through a max pool layer. And here we are not trying to reduce or perform any kind of action over here. all this max pool layer will do, this is usually 2 cross 2, right? Okay, this is 2 cross 2 matrix. So what this max pool layer will do, it will go through each and every layer of this image over here. So like, let's think that this is the max pool layer, right? And this will sit over here at this 4 pixels. And like, for example, let's say this has 6, 7, 9, and let's say 11, right? So these are nothing but the probability values. Okay, and it will choose the maximum value from this part. So it's going to be something like, it's going to create a pixel, and this would be 11. Now you might be wondering, right, like, why is it giving 11 value? Well, you see, as I mentioned, these are the probability values, right? As 11 is the highest value, it indicates that 11 is a place where we have highest probability of that particular feature. Similarly, this will go through each and every box. All right, and now the size of the image will reduce. Okay, so let me quickly show you by what. So now we are going to pass the max pool layer. After this, the size of the image will be reduced by half. That's going to be 4 cross 4, but number of filters will not change. All right, now we can pass this through another convolution layer. I mean to say, all of these steps can be repeated again, but once we are done with that, right, we'll flatten this entire layer, and this is going to be a simple artificial neural network. And every time what happens over here is, we are going to pass this through a multiple layers, or I can say as deep layers. Okay, and then we can perform our classification here. And another important thing that I forgot to mention over here is, in order to increase the linearity, right, we're going to also have an activation function over here. Usually I would be using ReLU. I hope you know what is ReLU, right? So what activation function does is, after reaching a certain threshold, it'll activate that part. So what ReLU does is, this is how the graph for ReLU does. And here it ranges from 0 and 1. And now in order to perform the classification, in our last output layer, right, I will be passing an activation function called as softmax. Because softmax gives me the probability which would range from -1 to +1. All right, so this is all about convolution neural network. Using deep learning, we can detect objects either by using RCNN model, which stands for region-based convolution network, or by using YOLO method. So moving ahead, I'll be talking about YOLO algorithm. Now you might be wondering, why do we have two different families for object detection, right? Well, you see, there's a lot of difference between YOLO family and RCNN based approach. In the RCNN based approach, it focuses mostly on division of an image into parts and then assign probability values to those parts. And whichever part has the highest probability, it's where we consider an object to be present. Whereas the YOLO framework focuses on the entire image as a whole and predicts the bounding boxes, and then calculate the class probability to label the boxes. The family of YOLO framework is very fast as compared to RCNN. YOLO algorithm has evolved over the years. It first started with YOLO V1. This model is also called as YOLO Unified. And the reason behind this is that it unifies object detection and classification model together as a single detection network. This was first attempt to create network that can detect real-time objects very fast. YOLO only predicts limited amount of bounding boxes to achieve the goal. The YOLO algorithm has improved over the years. Now we have YOLO V2, and the latest version of YOLO is YOLO V3. You see, the YOLO V1 framework makes several localization error, and YOLO V2 improves this by focusing on recall and localization. The YOLO V2 uses batch normalization, anchor boxes, high resolution classifiers, fine gradient features, and multi-level classification. And also it uses something called as darknet. All these features made YOLO V2 better than V1. Speaking about darknet, darknet is actually a pre-trained model. And here YOLO V2 was using darknet 19, which means it contained 19 convolution layer, 5 max pool layer, and a softmax layer for object classification. The latest model of YOLO is YOLO V3. This model is the fastest and most accurate object detection model. It accurately classifies the object by using logistic classification compared to softmax, which was used in YOLO V2. This makes us capable of making multi-label classification. YOLO V3, which also uses darknet 55 as a feature extractor. You see over here, YOLO V3 makes use of darknet 53, which means that there are 53 convolution layer. As a result of this, it can make more accurate predictions of an object. Now that we know what is object detection and what is YOLO algorithm and how to work with OpenCV, let me quickly move to my code editor and show you an application to detect objects in an image as well as in a video. All right, let me quickly jump to my code editor. So as you can see here, I'm in my code editor, and as I've mentioned earlier that I would be using Google Colab. Okay, so first off, let me import all the important libraries here. So I have imported my CV2, NumPy, Matplotlib, and so on. Okay, so let me execute this. So let me quickly move to the another tab and show you the official website of our YOLO algorithm. YOLO Algorithm webpage. Okay, and this is the official website for our YOLO algorithm. And as you can see here, we have multiple versions. We have different versions over here, and then we have YOLO v3, and then we have various versions, right? So in order to use this YOLO algorithm, we need to download this weights folder and also the configuration file. The configuration file is basically a GitHub repository. So let me quickly show you that. As I've already installed this, I won't be reinstalling this on my system, but it's pretty similar. All you need to do is click on weights and it'll automatically download this on your folder. And as you can see, I've already installed this weights folder as well as a configuration file. All right, so let me upload these files from my folder. Okay, so as you can see here, we have the Coco names. Coco names is nothing but the classes that have been pre-trained, right? So we'll have a Coco names, then we'll have the configuration file as well as the weights. And let me quickly open this. One thing that I would like to mention over here is that we have a couple of flavors of YOLO v3. One over here we have 360, 416, 608, Tiny, and SPP. Tiny is the one whose file size is pretty small. As I'm using Google Colab over here, I'll be using Tiny because I'm supposed to upload this file to this environment over here. So the first thing that we're going to do is get these files loaded over here. So let's give the name of variable over here as net. Okay, let's give it as network, or we can give it here as YOLO. Okay, and this would be cv2 dot DNN, which stands for deep neural network dot read network. All right, and now here we're going to pass an argument over here. We are going to pass our weights as well as a configuration. All right, so let me quickly copy the path for this and paste it over here like this. Similarly, we're going to copy the configuration file path, and let me minimize this over here and let me paste it over here. All right, so let's wait for 2-3 minutes because this is still uploading over here. So let's wait for like 2-3 minutes, and once that's done, we can execute our code over here. All right, so now that we have uploaded our weights folder, let me quickly execute this. And now what we'll do is, let us now import the classes. As I mentioned earlier, our Coco contains the list of names, right? It has the list of names that our YOLO algorithm is capable of detecting. And as is a pre-trained model, there are a couple of things. We can detect cats, we can detect dogs, horse, sheep, cow, elephant, bear, and many more. Let me now quickly import that and put them in the form of a list. So I've already imported matplotlib over here. So let's create a class, CLA, and this would be an empty list. All right, and now what we'll do is, as it's a file, we'll use this file handling with open, and we'll give the name of this place, that is a path. So let's copy the path over here. And then we'll also define the type of operation that we are doing. We're going to do read operation as F, right? And now what we'll do is classes. So this would be nothing but f.read. And now we'll have, as this will give the entire page, right? We want to split it in lines, right? So we'll have split lines. All right. So let me quickly execute this over here. Okay. So now let us see what is there for us in our classes. So let me have len, and then let me give a classes. So it should approximately show around 80. And if you want to see what these classes contain, they'll contain the name of the different objects that we can identify. All right. So let me change this back to the length and execute this. So now that we have our classes and we have loaded our model over here, so what we'll do is let's load our image. So let's take the same old image. Let's take this bus image over here. And in order to load our image, all I'm going to do is cv2.imread and pass the path over here. So I'll copy the path and just paste it over here. And let me change this back to the directory. All right. And we all know that this would read in BGR format, and we have to convert this to RGB format, right? So let's quickly get that done. Okay, so we'll give here as new image, or let it be like blob. Okay, blob, and this would be nothing but cv2 dot deep neural network dot blob from image. All right, so blob from image. And now what we're going to do is we'll pass our image over here, and then we'll pass. So obviously these values over here would be in the form of integer, right? And we have to convert that back to float. So we'll do the regularization by dividing all the pixels by 255. This will ensure that values are ranging from 0 and 1. All right. And now we obviously have to define the shape. If the image is pretty huge, right? So consider that we have this image over here. So if this image over here is like say 1000 cross 1000, right? So, and over here again, it's going to be 1000 cross 1000. Now we have to rescale this image, okay? Because an algorithm cannot read this huge image and it will take huge amount of computation power. Okay, so what we're going to do is we'll resize this image both on the x-axis and y-axis size to 320. Okay, so basically we're trying to reshape this. So let me quickly mention this over here. Okay, so this is where we can add our reshape image. So it's going to be 320 cross 320. All right, and then we'll have to pass the images 0, 0, 0. And then an argument over here which would say swap is equal to true. And the reason why we are using the swap RB, the reason is because we all know this is going to read in BGR, right? And we obviously have to interchange RG and B. So we'll have true over here. And then finally we'll be passing crop. We don't want our image to be cropped, so it's going to be false. All right, so let me quickly print this over here. Let me execute this line. Okay, we are having an invalid syntax, and the reason for this is because I have passed a full stop rather than a comma. And let me execute this once again. And you can see here that we have successfully run our image. So let me quickly run this and let's see the shape and size of this. So blob.shape. This is still a numpy array, so it's going to be shape. Okay, so we are not getting the shape over here, right? So blob, so it's going to be blob. So I've put here blob. So blob dot shape. So as you can see here, the weights have been changed. If you want to print this on your matplotlib, all you need to do is you need to reshape this, and it's going to be 3 channels over here. Okay, so let me quickly show you that as well. So this is an optional part to do. So to print image. So what we're going to do is we'll give an image over here, or let's give I. Okay, and what this I will contain is image blob, sorry, and this would be 0 dot reshape 320 comma 320 comma 1. All right, and now we'll just plot it I. And if we try to plot the blob directly, it's not going to plot. The reason is because it's not in the correct format. So let me quickly execute this now. So if you can see here, we have our images, right? This has been divided into 3 channels, that is R, G, and B channels. And that's the reason why we are getting 3 images over here. So now we have this blob, right? Now we are supposed to set this blob as an input image. And in order to do that, what we'll do is YOLO. Okay, this is the model or module that we have imported from outside. So we'll set the image, that is set input, and then we'll pass blob. And let me execute this. All right. And now we also have to define our output layer. So output layer names, and this would be dot get. All right. And we'll have unconnected output layer names. Okay. And now what we'll do is we're going to pass this for our output, right? So layer output, and this is going to be YOLO dot forward, and we are going to pass just the output layer names. All right, so let me copy this over here and paste it here. So all that is left over here is we need to read the image, we need to find where the bounding boxes are, and then we need to put the bounding boxes on our image. Okay, so in order to capture our bounding boxes, there can be multiple number of boxes in our image, right? So we'll create a list. So box, and we'll give here as array. So this will be boxes, and then we'll have confidence, in the sense by what confidence is the value being predicted, and this would be an array yet. And then we'll have class IDs, and the class ID over here refers to what we have imported, right? So in order to get this, we'll be using class IDs. So we'll run through an image for output in layers. That's going to be this one, layer output. And then we'll have for detection in output. Okay. And now we'll first capture the score. And this would be nothing but detection. So this would be like score, right? Score is nothing but an array. So what this output will give is, for every object that has detected, right, it will give an output over here from 0 to 18. And then the first 4 box, right, this is responsible for the position of our boxes. So here it gives X, Y, center, and other parameters. And rest of it, it gives me whatever the parameters we have, right? Like we have 80 parameters. It gives a confidence or probability of that particular character being in that box. Okay. So we'll calculate the score over here. So excluding the first 4 boxes, we'll have 5 over here. And then we'll also capture the class IDs. So class ID, that is np.rmax score. Okay, and let us also get our confidence over here. Confidence, this is nothing but score, and then we'll pass the class IDs over here. Okay, so if you want me to explain this, what is happening over here, see, we are getting this list, right? So by detection, we're going to get a list. Okay, and what the score ID is doing is we are going to get the place or the placeholder in that array where there is a maximum probability of that image. And what this class ID will do is it will just get the whatever the values there or the percentage of that probability. Okay, so now moving ahead, we'll have, in order to prevent multiple bounding boxes, we'll have confidence. All we are trying to do over here is we're going to set a threshold if the confidence is greater than 0.7. Okay, and then what we'll do is then we'll extract all our features. So we'll have center X. This would be nothing but, we obviously need an integer value over here. Detection, as I've mentioned, this detection, right? The first 4 boxes is responsible for giving us the X, Y, height and width. So it's going to be 0 times width. All right. And now similarly, we are going to do it for X, height and width. Okay. So let me copy this again and paste it here. This is for the height and then for the width. So let me just change the name to width and then we'll have height. All right. And then we also need to mark height over here. And similarly, we're going to do it over here. And now finally, to find the center value of X, we'll have X, which is nothing but int center X minus W by 2. All right. And similarly, we'll do it for Y is equal to int center Y. We're using this, right, the X and Y values in order to find the corners, right? So we'll similarly find it for Y, which is nothing but height by 2. All right. And now finally, all we need to do is we need to append these values to these boxes over here. So what we'll do is boxes, that is nothing but these layer. So it will be BOX, should be ES. That shouldn't be an issue. Dot append. We'll pass a tuple value here of X, Y, width and height. Similarly, we are going to pass the confidence values. That is nothing but this tuple confidence. So we'll append the values to the list, dot append. And then all we're going to do is float confidence value. So which is present over here. Okay, and finally we need to have class IDs, right? So let me get this as well. And then all we are going to do is append and then class ID. All right, so now that we are done with this, let me quickly execute this block of code over here. And let's see if we get any error or not. All right, so as you can see here, we have successfully executed our code. Now what we'll do is we'll see how many number of bounding boxes up there. And to do that, what we'll do is we'll find the list, or we'll just print the amount of elements that are present in the list. Okay, so what we'll do is length of boxes. Okay, and this should give us, okay, 2. That means whatever image we are passing, it is able to detect only 2 objects over there. All right. And now what we'll do is we have to obviously add these bounding boxes to our image, right? So we'll do indices, and this will be CV2 dot deep neural network dot NMS boxes. All right. And now what we'll do is we'll pass the boxes, that is nothing but the values over here. And then we'll pass the confidence. All right. and then we'll also pass 0.5 and then 0.4. All right, so let me quickly execute this. All right, so we are getting an error. That's because I have to put a comma over here, and let me execute this now. All right, so now what we'll do is we'll obviously have to add this. So we have to add the font and confidence to our image, right? So we'll give font. So let me give here. So this is nothing but cv2 dot font underscore. You can choose any one over here. I'm going to use Hashly plain, right? So we have over here, and then we'll pass colors to our font. That is nothing but colors. This is nothing but np.random. Okay, we don't want the same color, right? We want to pass random colors for each of our bounding boxes. So we'll give the range 255, and then size. This would be equal to the length of the bounding boxes. So size, this would be length. And then we'll also pass 3 over here. All right, perfect. So now all that is left is to add the images. So, okay, so let's see what is the issue over here. All right, so the reason why we are getting this is because I have forgot to mention uniform over here. So let me quickly mention that dot uniform, and let me execute this now. Perfect. Now what we'll do is we'll take each and every object over there and we'll add bounding boxes to this. And in order to do that, we'll use a for loop for I in indexes dot flatten. All right, and now we have to take our XY coordinates. So X comma Y comma width and height. This would be nothing but boxes, and then this is for that particular image, right? And now let's have a label. So here we are basically trying to add label. So this is going to be str classes. I hope you know from where we are getting these classes. We are getting these classes from here. We imported this Coco names, right? So we are importing the classes from there. All right, and then all we are going to do is pass class ID, and then we'll have a list. Fine. And similarly, we are going to do it for confidence. So we'll convert this to string, and then we obviously don't want it to be floating point number, so we'll round it off, and confidence, and then let's have it by 2 decimal places over here. And now for the color. Yep. So what is happening over here is we are just trying to extract each and every information from the list that we have created above. And now all we'll do is we'll add rectangular bounding boxes. To do that, we have cv2.rectangle, and then we'll have to define the image, the coordinates, that is x comma y, and then we obviously have to define the edges, right? So it's going to be x plus width, then we need y plus width, and the color, and then we'll have 1. The 1 over here refers to what is the size of the rectangular box you want. And now similar way, let's add the text. So cv2.put text. Obviously we want them in the image. All right, and now we have to pass all of these parameters. So it's going to be label, and then we'll give some space, and then give some confidence value, right? And then we'll also pass a couple of parameters, like where we want it. We want it in the top left corner, so it's going to be x, and then y plus 20. And then we'll have font. This selects which kind of font you want, font size, and the background. So we'll keep a white background over here. Okay, so this is not the background, this is what color of text you want. So it's going to be 255, 255, 255. So it's white color, and then the size of a bounding box. So let me quickly execute this and see what happens, whether we get any error or not. All right, so as you can see, we have no errors which are present over here. So what we'll do is we'll try saving this model, or we can also see it over here. So in order to see this, all we need to do is plt.imshow and pass the image name, and then we can see the image. All right, so what's happening over here is it's trying to read the original image, right? So let me now quickly show you if we have any bounding boxes in our image. So as you can see here, right, there's a thin box which says person with a 99% probability, but we are unable to see it. So what we'll do is I'll just increase the size of this over here, and let me rerun this from the beginning. All right, so let's see what happens. Okay, so as you can see here, it's detecting this person with 89% probability, right? So let's do one thing. Let's take one more image and see what happens. So let's take this image over here and let me quickly upload this. Okay, so let's copy the file path. All right, so let me quickly just change this value over here and give it this as a root directory. So all I have to do is dot, and let me execute this from the start, right? So let me execute this. So as we can see here, we have a couple of images which bounding boxes. So in order to look at these bounding boxes clearly, let me save this image so that we can zoom in, right? So in order to save the image, all we need to do is cv2 dot im, right? All right, give the path where you want to save this. So let's give image.jpg, and then which image you want to save, right? So it's going to be img over here, and let me quickly execute this. All right, so if you're getting true over here, this means that we have our image over here, and let me quickly run this up for us. So as you can see here, this is detecting a person, and as there are too many number of people over here, so it's going to detect a lot of people, right? So that's why it has given a single bounding box, and it has detected a person over here. All right, as I mentioned earlier, using OpenCV, we can take three types of inputs, right? One is a webcam feed, another one is the images, another one is a video. Although the procedure remains the same, only thing that you're going to do is you're going to change how you take the input and put all of this in the form of a for loop. All right, guys, with this, we have come to the end of our session. I hope you enjoyed and learned something new. If you have any further queries or doubts, please do mention them in the comment box below. Until next time, goodbye and take care.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!